Here are answers for the day one bell work. The directions say draw example molecules of our choice. So I'm going to draw some examples on the screen. There's no guarantee that the one I pick is the same as what you pick. And for each of these, we need to make two drawings, a complete structural formula and a line drawing. So an alkane is a hydrocarbon with only single bonds. It's my choice what I want to draw. I'm going to make them pretty simple. So my example alkane is ethane, 2 carbons and 6 hydrogens. Here is the complete drawing. And here is the line drawing. It's not shown, but there's a carbon atom on both ends of that line segment. I drew ethane. You could have made methane, propane, butane. You could have made a branched alkane if you wanted. Now question B, any alkene that I want. I'm going to make this alkene. And then complete it with hydrogens. Now I'm going to make this same drawing using the line technique. I want propene with a double bond located between the first and second carbon. Now question C, any alkyne I want. I'm going to make this one. And complete it with hydrogens. My chain has 4 carbons, which creates the first name bute. And then there's that triple bond there in the middle. This is 2-butyne. The 2 in the name 2-butyne tells me that the triple bond is located between the second and third carbon. Another way to think of it is the triple bond is the second bond in the chain. I'm going to redraw this same molecule. There's 4 carbons. Now I want to locate that triple bond in the correct spot. The triple bond is in the center of the molecule. It's between the second and third carbon. It's located right here. Now, if you were to look at this drawing in a book or online, it's going to look like this. Notice it doesn't have that zigzag appearance. And there's a reason for that, because in three-dimensional space, a triple bond has that linear arrangement to it. And these drawings that we make are trying to duplicate what the molecule looks like in actual space. So the more accurate drawing of the molecule is this one here. But if you draw it like this, that's going to be okay with me on a quiz. Now an arene. I can draw any arene I want. The most famous one is benzene. That's the one that we practiced in class the most often. So benzene is a hexagonal arrangement of 6 carbon atoms with alternating single and double bonds. So one at the top, one here and one over here, one here and one over here, and one at the bottom. Single, double, single, double, single, and double, and then complete it with hydrogens. Now the line drawing for benzene. One way to draw it is like this. And show the alternating single and double bonds. However, remember that when you draw these, we're trying to duplicate what it actually looks like the best that we can. The single and double bonds in benzene resonate. In a benzene molecule, the location of the single and double bonds changes all the time. For instance, between this carbon here and this carbon here, there's not always a single bond. Sometimes there's a double bond there, and the single bond would be over here because the electrons are always in motion. So there's a way to show that with the line drawing. Make the hexagon shape. And instead of drawing lines to show single, double, single, double, single, double, a technique is to draw a circle in the center. This sketch is a picture of benzene, but you didn't have to draw benzene. There are many arenes. Another well-known one is toluene, Or think of all the possible molecules that have a benzene ring in them, but then there's branches attached to that ring.